It's 1878. Sir Francis Galton gives a remarkable talk. He's speaking to the Anthropologic Institute of Great Britain and Ireland. Known for his pioneering work in human intelligence, Galton is a brilliant polymath. He's an explorer, an anthropologist, a sociologist, a psychologist, and a statistician. He's also a eugenist. In this talk, he presents a new technique by which he can combine photographs and produce composite portraits. This technique could be used to characterize different types of people. Galton thinks that if he combines photographs of violent criminals, he will discover the face of criminality. But to his surprise, the composite portrait that he produces is beautiful. Galton's surprising finding raises deep questions. What is beauty? Why do certain configurations of line and color and form excite us so? For most of human history, these questions have been approached using logic and speculation. But in the last few decades, scientists have addressed the question of beauty using ideas from evolutionary psychology and tools of neuroscience. We're beginning to glimpse the why and the how of beauty, at least in terms of what it means for the human face and form. And in the process, we're stumbling upon some surprises. When it comes to seeing beauty in each other, while this decision is certainly subjective for the individual, it's sculpted by factors that contribute to the survival of the group. Many experiments have shown that a few basic parameters contribute to what makes a face attractive. These include averaging, symmetry, and the effects of hormones. And let's take each one of these in turn. Galton's finding that composite or average faces are typically more attractive than each individual face that contributes to the average has been replicated many times. This laboratory finding fits with many people's intuitions. Average faces represent the central tendencies of a group. People with mixed features represent different populations and presumably harbor greater genetic diversity and adaptability to the environment. Many people find mixed-race individuals attractive and inbred families less so. The second factor that contributes to beauty is symmetry. People generally find symmetric faces more attractive than asymmetric ones. Developmental abnormalities are often associated with asymmetries, and in plants, animals, and humans, asymmetries often arise from parasitic infections. Symmetry, it turns out, is also an indicator of health. In the 1930s, a man named Maximilian Factorowicz recognized the importance of symmetry for beauty when he designed the beauty micrometer. With this device, he could measure minor asymmetric flaws, which he could then make up for with products he sold from his company, named brilliantly after himself, Max Factor, which, as you know, is one of the world's most famous brands for makeup. The third factor that contributes to facial attractiveness is the effect of hormones. And here I need to apologize for confining my comments to heterosexual norms. But estrogen and testosterone play important roles in shaping features that we find attractive. Estrogen produces features that signal fertility. Men typically find women attractive who have elements of both youth and maturity. A face that's too baby-like might mean that the girl is not yet fertile. So men find women attractive who have large eyes, full lips, and narrow chins as indicators of youth, and high cheekbones as an indicator of maturity. Now, testosterone produces features that we regard as typically masculine. These include heavier brows, thinner cheeks, and bigger squared-off jaws. But here's a fascinating irony. In many species, if anything, testosterone suppresses the immune system. So the idea that testosterone-infused features are a fitness indicator doesn't really make a whole lot of sense. Here the logic is turned on its head. Instead of a fitness indicator, scientists invoke a handicap principle. The most commonly cited example of a handicap is the peacock's tail. This beautiful but cumbersome tail doesn't exactly help the peacock avoid predators and approach peahens. Why should such an extravagant appendage evolve? Even Charles Darwin, in an 1860 letter to Asa Gray, wrote that the sight of the peacock's tail made him physically ill. He couldn't explain it with his theory of natural selection, and out of this frustration, he developed the theory of sexual selection. On this account, the display of the peacock's tail is about sexual enticement. And this enticement means that it's more likely that the peacock will mate and have offspring. Now, the modern twist on this display argument is that the peacock is also advertising its health to the peahen. Only especially fit organisms can afford to divert resources to maintaining such an extravagant appendage. Only especially fit men can afford the price that testosterone levies on their immune system. And by analogy, think of the fact that only very rich men can afford to pay more than $10,000 for a watch as a display of their financial fitness. Now, many people hear these kinds of evolutionary claims and think they mean that we somehow are unconsciously seeking mates who are healthy. And I think this idea is probably not right. Teenagers and young adults are not exactly known for making decisions that are predicated on health concerns. But they don't have to be, and let me explain why. Imagine a population in which people have three different kinds of preferences: for green, for orange, and for red. From their point of view, these preferences have nothing to do with health. They just like what they like. But if it were also the case that these preferences are associated with a different likelihood of producing offspring, let's say in a ratio of 3 to 2 to 1, then in the first generation there would be 3 greens to 2 oranges to 1 red, and in each subsequent generation, the proportion of greens increase so that in 10 generations, 98% of this population has a green preference. Now, a scientist coming in and sampling this population discovers that green preferences are universal. So the point about this little abstract example is that while preferences for specific physical features can be arbitrary for the individual, if those features are heritable and they are associated with a reproductive advantage, over time they become universal for the group. So what happens in the brain when we see beautiful people? Attractive faces activate parts of our visual cortex in the back of the brain, an area called the fusiform gyrus that is especially tuned to processing faces, and an adjacent area called the lateral occipital complex that is especially tuned to processing objects. In addition, attractive faces activate parts of our reward and pleasure centers in the front and deep in the brain. And these include areas that have complicated names like the ventral striatum, the orbitofrontal cortex, and the ventromedial prefrontal cortex. So our visual brain that is tuned to processing faces interacts with our pleasure centers to underpin the experience of beauty. Now, amazingly, While we all engage with beauty, without our knowledge, beauty also engages us. Our brains respond to attractive faces even when we're not thinking about beauty. We conducted an experiment in which people saw a series of faces, and in one condition, they had to decide if a pair of faces were the same or a different person. Even in this condition, attractive faces drove neural activity robustly in their visual cortex, despite the fact that they were thinking about a person's identity and not their beauty. Another group similarly found automatic responses to beauty within our pleasure centers. So taken together, these studies suggest that our brain automatically responds to beauty by linking vision and pleasure. These beauty detectors, it seems, ping every time we see beauty, regardless of whatever else we might be thinking. We also have a beauty is good stereotype embedded in the brain. Within the orbitofrontal cortex, there's overlapping neural activity in response to beauty and to goodness. And this happens even when people aren't explicitly thinking about beauty or goodness. Our brains seem to reflexively associate beauty and good. And this reflexive association may be the biologic trigger for the many social effects of beauty. Attractive people receive all kinds of advantages in life. They're regarded as more intelligent, more trustworthy. They're given higher pay and lesser punishments, even when such judgments are not warranted. These kinds of observations reveal beauty's ugly side. In my lab, we recently found that people with minor facial anomalies and disfigurements are regarded as less good, less kind, less intelligent, less competent, and less hardworking. Unfortunately, we also have a disfigured is bad stereotype. This stereotype is probably exploited and magnified by images in popular media in which facial disfigurement is often used as a shorthand to depict someone of villainous character. We need to understand these kinds of implicit biases if we're to overcome them and aim for a society in which we treat people fairly based on their behavior and not on the happenstance of their looks. Let me leave you with one final thought. Beauty is a work in progress. The so-called universal attributes of beauty were selected for during the almost 2 million years of the Pleistocene. Life was nasty, brutish, and a very long time ago. The selection criteria for reproductive success from that time don't really apply today. For example, death by parasite is not one of the top ways that people die, at least not in the technologically developed world. From antibiotics to surgery, birth control to in vitro fertilization, the filters for reproductive success are being relaxed. And under these relaxed conditions, preference and trait combinations are free to drift and become more variable. Even as we are profoundly affecting our environment, modern medicine and technological innovation is profoundly affecting the very essence of what it means to look beautiful. The universal nature of beauty is changing, even as we're changing the universe. Thank you.